So, my name is Dmitry Ornatsky. I'm with Grid Dynamics, and we are a professional services company. And among other places on Earth, we're present here in Krakow. So check our booth out. It's next to the entrance on the left. So I'm going to be talking about chatbots and conversational user interfaces in general. But I will be looking at it from more a businessy perspective. So I won't be dedicating that much time to machine learning and artificial intelligence technologies behind it, behind speech recognition, behind dialect control, and so on and so forth, even though I will mention where these things belong in the broader picture, right? So I'll be covering with, I will start with explaining why on earth we need these things, right? Because a lot of people seem to be confused that it seems like a gimmick. Well, I have my websites, I have my mobile applications, and why on earth do I need to talk to a machine to get things done? We'll be covering how much of it is hyped up and how much of it is actually useful. I'll be talking about some real-world applications and e-commerce specifically, because that's a domain that's dear to my heart. And as I said, I'll be touching briefly, well, not so briefly, on technology behind chatbots, and specifically technology that enables people who are not necessarily artificial intelligence experts to build something that's useful. So why do we need another type of interface? So let's start with the definition. A virtual assistants or conversational user interfaces are sort of generated agents that simulates a conversation and solves a business problem for you. And like business problem is consultants speak for something useful, but it doesn't have to be a business problem like in a money-making business, right? It can be anything with a real-world case. And it incorporates various bits: natural language processing, dialect control, obviously domain knowledge, and a few other aspects of natural language processing, depending on whether you're dealing with speech or written text, what kind of language are you dealing with, and so on and so forth. And you communicate with these things through text, through speech, and it can talk or write you in response. So let's talk about why. The first reason to use this kind of interface is simply because instant messaging apps is where people are at anyway, and I'm guessing some people in the audience are texting right now, which is fine. We do that, and my generation, and I think I borderline qualify as a millennial, we hate voice calling, and the people who are younger than me probably never do that at all. Unless I absolutely have to. So the texting is a preferred way to interact with humans. And in sort of customer support scenarios, whenever you want to make an inquiry of sorts, a chatbot is probably a second best thing than an actual human being, because it responds instantly, it's available 24/7, and for the business you're interacting with, they're probably much cheaper. That answers the question of why that and not an actual phone call, but it doesn't answer the question of why that and a traditional web UI of sorts. So one problem with traditional web UIs and visual UIs in general is that as your system becomes more complex, there are sort of non-mainstream use cases that are very hard to discover. We all know how to shop on Amazon or any other retail website. They're all pretty similar in appearance, right? We know how to place our order, there is a shopping cart, there is a checkout button, and so on and so forth. Once you want to do something not so trivial, something not mainstream, like maybe you want to change the delivery date, it's pretty hard to discover these parts of UI. And the way you go about it is you typically make a search, or you contact a support person, or you're looking for some FAQ document, and so on and so forth. So if you eliminate that part and go straight to a natural language query you're trying to make, and make the system act on it, that seems a natural thing to do, because discovering these non-obvious use cases usually involves some kind of natural language query. And in addition to that, text-based and speech-based interfaces are obviously major enablers for those who cannot necessarily use traditional visual UIs, visually impaired people who cannot use their fingers that well, And even able-bodied people were in the car, for example. So that answers the why part of it, right? How well does it all work? So at this point, I think we can all agree that Siri, Google Assistant, and the like are genuinely useful. Some people use them to just schedule their appointments and set their alarm clocks, but that's all right. They can do much more than that. And even if you don't have the budget of Microsoft, Amazon, Google, and so on and so forth, you probably have the budget to do something that's very focused and still useful. So we'll be discussing some toolkits and technologies that allow you to do that. Some even don't require that you're able to code, even though more advanced scenarios obviously require that. So these things are genuinely useful. And there are some horror stories about bots that used reinforcement learning and were deployed in the wild, and at some point during their lifetime, typically within the first 24 hours, they basically went haywire and became sort of racist and generally unpleasant in many ways because people on Twitter taught them to be that way. That happened once or twice at least. One example is Microsoft Hi, which they deployed on Twitter. They quickly shut it down, and as far as I know, its successor is much more pleasant to talk to. So they kind of suppressed these parts of the chatbot's brain that were responsible for racist slurs. So how much of it is hyped up? So this chart you're seeing here comes from Gartner, and Gartner is this analytics company that profiles the industry, sees what's out there, what's new, what's becoming mainstream, and they generally, their impression, and well, it kind of matches my ad hoc observation, is that every new technology follows this curve where it's first hyped up to the point where it's talked about much more than it's actually used. And then it slides down into this sort of valley of usefulness and it becomes mainstream and not so sort of shiny and new, but much more genuinely useful. And some bits of it, some applications die out, and some bits of it remain. So if you take a look at this graph here, so you can tell that, for example, virtual reality has become somewhat mainstream. You can buy gaming consoles and home appliances that are VR enabled. And chatbot technology, as of last summer, so it's moved down this curve somewhat within the year, is at the peak of a hype, or at least it was a year ago. And in 5 to 10 years, we will see how it becomes sort of commoditized, how it becomes more mainstream, and more people are actually using it. And again, the cases that are not so popular or useful will die out. So I'm going to be covering an example of the one sample application in retail, right? So because that's what I know best. But before I go there, let's take a look at some of the sort of fundamental black box vision of what a chatbot is. So there is a class of machine learning models that are called sequence-to-sequence. And that's what they do. They take a sequence of text, well, it's typically text, and then transform it to another sequence of text. And if the corpus of documents they were taught on is bilingual, you get a machine learning solution. If it was a corpus of dialogues, you get a chatbot. Now, the thing about that kind of chatbot is it can be very fluid in how it keeps up with the conversation, and it's very human-like. And well, if you ask him or her, however you prefer your chatbots, what's the weather is like, and they will respond, it's 90 degrees Celsius outside and a bit windy. And they will respond that way because at some point in the past, at some place on Earth, that was the case. So they're like a talking parrot in that respect, right? Very intelligent, very smart, who can keep up with your conversation perfectly. They will keep you company, but they have no domain knowledge or any knowledge about the outside world. So any kind of useful chatbot or conversational user interface in general will have to sort of be on some point of the spectrum between dialogue fluidity and ability to converse on any topic, and be knowledgeable about something useful and being able to apply this knowledge. So any kind of real-world chatbot will have some goals that it will be capable of achieving and will be tuned and programmed to achieve them. So here are some examples from retail, right? So one case is mobile shopping through instant messaging. You may tell your chatbot to find you some, I don't know, blue jeans or any other kind of apparel, or maybe you're shopping for artwork, and you can get recommendation based on your past shopping history, your profile, and whatever. Maybe they will analyze your other conversation, figure out your interest and sort of propensity scores based on that. Well, that's sort of gray area when it comes to privacy and GDPR protections, but well, if you allow them to do that, they may very well be trained on that. There is conversational search and browse, which again I will be touching in a bit. So this is basically a use case when you say you make an inquiry about what you where you want to go, and then the bot will sort of steer you towards a particular category of merchandise or goods based on what they have in stock and what they don't, and how well your query matches the catalog of the retailer. There is obviously voice-enabled home shopping, something that Alexa obviously has been pushing for. And I mean, ordering something that you know you don't need to try on, like, I don't know, laundry detergent, right? You don't need to browse for it. You're typically using the same brand all over and over. So there's that. There's also customer services that are not so specific to retail and can be replicated across many customer-facing industries. Order management, loyalty programs, help desk scenarios, and so on and so forth. Maybe even IT support, or at least some parts of it can be automated that way. So let's talk about conversational search for a while. So this is the kind of UI you're presented with on your run-of-the-mill e-commerce website. And what often happens is that you get this. Maybe your query is too narrow, maybe the search doesn't work that well, maybe they're out of stock. And this is every merchandiser's nightmare, because, well, there's no way you convert this kind of search to a purchase. And they're like, this is their main KPI. So what you want to do in this case is make customer reformulate or redefine the query so that it brings at least something. And one way to do that is to have the search box and like use it like normally. But once you get to that 0 results screen, a virtual assistant pops up, and they tell you, well, you've been searching for this green cold shoulder mini dress. We have those in different color. Or maybe you're willing to go for a slightly longer dress or something else. And it can be vice versa, right? So you can get too many results and be swamped by them. And instead of browsing this practically infinite number of products, you're advised to narrow down your query. Maybe your search matches 2 different categories, completely different categories of products. Maybe you're looking for, I don't know, Avengers merchandise, and it matches both posters and T-shirts or something else. And typically you're looking for something more particular, right? So you're not willing to go in all directions. So this kind of assistant can help narrow the query down or broaden it to drive the customers to what they want. And it has to work across multiple channels, which may be very different. So you may be using your mobile phone, and again, you're interacting with the chatbot through this narrow window you typically use for texting. You may be on your desktop computer and using a normal desktop website. You may be using your smart speaker, and not all kinds of results feed all these channels well. So for example, if you're on a mobile phone, you want your grid to be narrow, and you probably want the descriptions to be shorter, and probably you want fewer fields on the UI. If you're on Alexa and you found 40 varieties of blue jeans, you don't want to be read all 40 descriptions out loud. Maybe you want to filter out swear words if they happen to be in this catalog. Maybe there are more peculiarities you want to adapt to. So the technology that underlies all that has to be capable of adapting to a particular channel. It has to work with natural languages, both ways. It has to be able to accept an inquiry in a normal language, has to be able to respond in it through text or voice, and it has to connect to your sort of line of business or domain applications on the back end. So let's talk about what enables all that, right? So this is the kind of general architecture that addresses all this stuff. So on the far left, you have your channels, your telegrams, your instant messaging apps, your Alexas, whatever you use to actually feed speech into the system. On the right, you have your far right, you have your regular lines of business applications, your data lake, where you collect the data which you haven't yet decided what you're dealing with, your traditional databases that serve customer requests, and probably the kind of backend you would normally have for any kind of business system or e-commerce in particular, e-commerce system in particular. And between those, you have adapters that sort of apply the specifics of how your channels interact with the outside world too, and kind of massage the requests for the system to understand them. And you have your chatbot core capabilities: natural language understanding, generation, a particular set of intents that it's trained to recognize, and also a dialogue manager, which is essentially something that's capable of steering the conversation one way or another, depending on what the customer wants. You may or may not have a conversation history, which, apart from audit purposes, may be used to apply some reinforcement learning and train the model further. Again, this is a shaky ground when it comes to kind of GDPR regulations, so your mileage may vary and you may put a giant legal disclaimer before you do that, but that's something that makes sense practically from the chatbot effectiveness standpoint. And here is a sample architecture of what we did for conversational search, right? So we use Dialogflow, which is a product from Google. It's been formerly called API AI, and they acquired it, I think, last summer. I'll talk about that in more detail in a bit. We used MongoDB just because we had it lying around, and for conversational history, and we had Solar Tagger because even if you don't have a chatbot, you probably want to have some natural language understanding capabilities in your e-commerce search, simply because the way people talk to this kind of systems is very different from the way they talk to each other, and they have some specialization in reality. So let's talk about what it means to understand natural language. First part of it is identifying the task, right? What is it that users try to do? The other part is extracting all the parameters of what they're doing with the system. So, and that entails a bunch of linguistical challenge. I'm not a sort of linguist, but I've dealt with e-commerce search systems for a while. So it entails stuff like stemming, finding collocations, for example, multi-word synonyms to certain words, recognizing named entities, brands, colors, so on and so forth. Parts of speech tagging, whether it's a request or an inquiry or something else. Semantic roles labeling, which again is essentially a way to infer intent from the query. And it gets trickier as you broaden the range of languages you're able to understand. And on the output part of it, there is action you want your system to take, probably the response you're giving to your user, and a bunch of parameters to feed into your backend systems. So as I said, the language of, for example, e-commerce domain can be substantially different from the language of everyday use, right? So when you're asking for silver jeans for something that's completely agnostic of retail space, that may mean make no sense, right? It can mean that you're looking for silver colored jeans or jeans made of silver or something even more nonsensical. The reality of it is that silver jeans is a brand, and you should have recognized that. So there's a very particular dialect of English, which we will call shopping English, which the system has to adapt to. And this is an example of how this kind of reasoning might go. So do you have green cold shoulders minidress, right? So do you have as a sign that you want to make a request? You're looking for a particular product. Green is obviously color. Cold shoulders is a type of silhouette, and minidress is a product type. And two, you have to allow some tolerance in how people formulate their requests, right? So they will be making typos. English may not be their first language. There are all kinds of peculiarities you have to deal with. And you have a similar challenge on the attribution side of things, right? So your database may not be perfect. So your suppliers may have different idea of green. And this green mini dress may not be actually the kind of green the user expects. And you may apply some machine learning techniques there to detect misattribution and sort of label these potentially misattributed parts for actual humans to review, or even fix them automatically based on the images you have of the product. But sort of that's a completely different story, but this is an indication of how complex e-commerce search may become. And once you've done that and you have your parameters and actions, you want to generate a response in addition to actually fulfilling the request, right? So natural language generation is somewhat simpler than that, because your bot is kind of expected to sound more robotic than actual human. And if you just pre-generate a bunch of templates and fill in the gaps with parameters you've derived from the actual request, you're basically good. So that part is usually trivial, apart from the speech generation part, which again you probably don't want to write yourself. There are a bunch of technologies that allow that, starting with a say utility on my backbook. So there's plenty of solutions to that. Oops. So if you go back to that picture, there was this adapter box, right? And what it does essentially is it adapts the system to a particular channel. As I said, the grid on the mobile phone is probably smaller than it is on a desktop website. Your Alexa, you don't want your Alexa or Google speaker to be as wordy as your desktop website. So there are many adaptations that have to be made, and this is basically your configuration that allows the channel to work a particular way while using the same conversational core. As you can see, the grid on the desktop side is much wider than it was on the mobile phone. So one solution to all these problems, well, at least some of them, are systems like Dialogflow. So what these things do is essentially enable you to use a pre-built bricks that cover most of the areas on this diagram. If you ever interacted with Dialogflow, it doesn't appear to be using like all the heavy lifting that happens on the AI side of things is completely abstracted away and hidden from you. For example, their conversational engine, their ability to understand natural language, was pre-trained on a large corpus of text, and the way you specialize it towards your particular use case is by providing sample requests, the way you expect your users to talk to the system and mapping them to user intents. And this technique is called transfer learning, where you essentially take a pre-built, pre-trained model and build a more specialized model by sort of providing additional training data. And that's what Dialogflow does, and that's the API AI know-how which they were acquired for. There are a bunch of systems like that. There's with AI, there's Amazon Lex, there's ChatFuel, and a bunch of others. So if you really want to select, you have to look at some of the comparisons that are out there. The difference between them can be subtle, or it can be a complete blocker for you. For example, some of them do not allow dialogue control, basically steering the users toward the particular response or in a particular direction without you actually writing the fulfillment logic or callbacks. Dialogflow does that. It can map your request to a particular response, and it can call a webhook on the backend as a byproduct. It also supports something called slot filling, which is essentially a way of engaging in a lengthy conversation and obtaining information as you go, where you would provide your name, your address, and so on and so forth, basically like a wizard. But in that sense, it's not in that case, it's not linear, and it relies on conversation rather than providing you with a bunch of web forms. So it is extensible in many ways. The primary way of extending it is by providing some kind of a web application on the backend that this thing will call. And if you don't want to mess with like nitty-gritty details of deploying a web service, you will use Google Functions, which is their sort of AWS Lambda style serverless platform, and you write some Node.js code and then it will deploy it for you. And then which you can call again from Dialogflow. If you don't want to do that, you're free to choose whatever technology you want, as long as it's accessible from Google servers, right, network-wise. If for some reason you don't want to use one of those systems, and one reason I can give you is that they're throttling you heavily, so you're not given infinite number of requests, even if you're paying for the service. So if you're under heavy load or your needs are different from what Dialogflow provides, for example, the conversational engine you're building may in itself be a machine learning system. For example, it can steer the user towards a particular flow of the dialogue that is more conducive to actually making a sale, and you're getting this intelligent virtual salesman that way. So Dialogflow will be either have to be heavily extended or replaced altogether. So one interesting library that we found is called Deep Pavlov, after the famous Russian physiologist, and it's actually authored by Moscow Institute of Physics and Technology. They have some sponsors that have helped them with it. And it's basically a modular platform that does about more or less the same things as Dialogflow, but its parts are pluggable. It has some sequence-to-sequence models to help you with sort of small talk. It has some intent classification libraries, which are again pluggable. If you are dissatisfied with that part of the system, you can plug in your own machine learning model. It has a bunch of tools for simulating conversations, some pre-trained domain agents, which, by the way, Dialogflow has as well. It has conversations to test against based on a particular real-life situation. So there is this whole spectrum of tools, but it's a alpha version, so you're basically getting yourself ready for a rough ride when you're using it. And this is basically their architectural diagram that indicates of how much is there, right? So one interesting area I see here is that it helps you with actual simulation, well, something that Dialogflow may not be necessarily optimal. So to recap, chatbots are genuinely useful in the sense that they solve real-world problems, and they're useful. They may be preferred not just as a cost-saving measure where you don't want to deal with an actual human, but they're actually maybe preferred by your customers because, well, the value of instant response and being able to discover these use cases that even the support person may not be necessarily aware of immediately is of huge value. Building them is not too hard to the point where completely non-technical people can do that. If you're capable of writing some code, there's even more to that. If you have machine learning experts on your team and capable of specializing the models that are out there, well, you basically have the full arsenal of tools to build something that's even more innovative than that. And there is room for innovation even if you're not innovating in the fundamental areas behind it, such as natural language processing, simply because these kind of dialogue control techniques have a wide range of possibilities when it comes to achieving things through dialogue. You're basically getting a virtual shopping assistant experience or virtual sort of decision support system kind of thing with a conversational interface. And there's simply a lot of cool technology underneath, right? So if you want to explore it in depth, instead of like focusing on practical use cases, there is a lot of room for that. Obviously, natural speech recognition and processing are areas of where investment is massive, and there is a lot of innovation. Just yesterday, I was watching this Google I/O thing where they demonstrated basically a conversational interface that is facing in another direction. So you basically tell your assistant to schedule an appointment for you, and they will actually call a nail salon or your mechanic or whatever it is you want to schedule for, and they will schedule an appointment on your behalf, handling the conversation like you would, like telling that, well, 1 p.m. doesn't quite work, 10 a.m. is better because, well, we're just changing the tires and that's it, so it's not going to take long, and they're explaining all that to whoever is scheduling your appointment. So it's kind of fun to witness how these things evolve. That's all I have. So any questions? Yes, this gentleman on the left.
How do you measure the success of such a chatbot? Can you automate it in some way, or do you have to check with regular users how they're using it, what feedback you're getting from them, or can you have some tests to verify if the chatbot works as you want it?
Yes, that's a good question. So there are two ways in which you can measure the success, right? One is sort of business level. If your chatbot is intended to convert your users into buying customers, that's one metric you can apply, right? There are technological metrics that can apply to different parts of the system. For example, that initial part of the conversational interface where you map written language to user intents is essentially a classification problem in machine learning terms, right? And these are measured in terms of precision and recall, in terms of false negatives and false positives. And you can pick a data set of requests that weren't classified, or you suspect they were classified erroneously, and you ask actual humans to label them. And based on that, you can measure your precision and recall at least some sample size, right? So the usual statistical methods apply here. So these are basically two ways in which you can measure the effectiveness of the thing. Yes, there is a hand on there.
More of a philosophical question, really. I've been working on a chatbot virtual assistant for my company for about 9 months now. And what I've noticed that even though the customers are being told that they're actually talking to a virtual assistant, it almost feels like they're taking it for granted, like that it's a robot they're talking to. And then, if needed, they can then escalate it to an actual person. As you mentioned, and what I wanted to mention in my question as well, Google has introduced, well, a iteration of Google Assistant that can actually speak like a human. Where do you think is that line where we can start accepting that, well, we can actually talk to a robot just like as we do to a human, and without being scared of the various threats that are being pushed to us by the media of, chatbots getting smarter?
So I guess the fears come from this kind of the notion of this kind of all-encompassing human-like AI that's general purpose. If as long as you're sort of narrowing down the goal of a chatbot towards a very particular set of skills or requests it can fulfill, people will understand that they're talking to a machine, to a kiosk, essentially. What happens if bots will become indistinguishable from actual humans? I don't know. I mean, I think we've yet to come a long way before that happens, to be honest. And if it does, well, who knows what's going to happen? All the kinds of ethical problems explored in science fiction of whether what's the borderline, what's the red line between a program that is indistinguishable from an actual human and an actual human. Well, I don't know, to be honest. I wouldn't be able to elaborate on that more than philosophers and science futurists and science fiction writers that already did. So I guess we'll see. Uh-huh. Can have what? Pass a Turing test. So Turing himself, I believe, said that this test is A, useless, and B, meaningless, because, well, if it's a heavily like orchestrated deception of some sort, and like the Chinese room sort of experiments are a proof that it doesn't necessarily involve any intelligence in human understanding of intelligence, right? So if you're so predictable and you're going to use it to achieve certain goals, you can put on a deception that's very convincing. And well, I doubt that anyone at this stage will say that this Google Assistant is a subject of human rights of any sort, right? And still, it's very convincing and deceptive. So I don't think that this is what's separating personhood from a computer-generated assistant. I don't know where the line is, but it's not there, is what I'm saying. That's it. Thank you.